Hello everyone, in this video we're going through LeetCode number 42, trapping rainwater. For this problem we're given n non-negative integers representing an elevation map where the width of each bar is 1. We want to compute how much water it can trap after raining. Now just from the problem itself it might seem a bit confusing, but we'll go through a few examples and hopefully it's more clear. So let's look at the first example. We're given this array heights, and we can see that it is represented in this elevation map. Essentially, the height at some index correlates to the bar at that index. So if we have a 3, that means we also have a bar of 3. Then we're tasked with finding how much water we can store between two boundaries. So for this example, if we count up all the water blocks, we can see that we have 1, 2, 3, 4, 5, and 6 water blocks. Hence the output is 6. To solve this problem, it's important to make the observation that each unit of water is bounded on its left and right by some bar of greater or equal heights. So for example, if we look at the water blocks in this index, we see that they're bounded by this bar and this bar. It also explains why we can't store water at this location, because it would just spill out on either side. And because it's not bounded on the left nor the right by a bar of greater or equal heights. With that being said, we can just keep track of the left and the right maximum heights and compare it with the current heights. That is, if we know the maximum height to the left and the maximum height to the right, we'll simply take the minimum of them. So if we take the same index as we showed previously, we'll see that the elevation maximum to the left is 2 and the elevation maximum to the right is 3. And if we take the minimum of these, we'll take 2. And then we can subtract the potential water level from the heights. And that will give us the amount of water at that index. And if we do that for each index, we'll get the total amount of water that can be trapped within this elevation map. To show you what that will look like is we can begin by initializing a left array and a right array. So if we start at the first index, we can see that it has actually no bars to the left, so it will have a left maximum of 0. For the second one, we see that it's 1, and there are none to the left that are greater or equal to 1. So the left max until this point will be 1. Then we have a 0. Well, we've already seen a maximum of 1, and the maximum between 1 and 0 is 1, so we'll have a left max of 1 until this point, and so on. A similar method is used to build the right array, but instead of starting from the start of the array, we'll start from the end and move backwards. If you continue out this algorithm, you'll see that the left and right arrays are exactly the ones that I've written down on the screen. Then we can go through the array and calculate the total water at each index. For example, the water at index 5 is the minimum between the two, so the minimum of 2 and 3, which is just 2, and we'll subtract the heights of the index, which is 0, which will give us a water level of 2. And if we do this for all of the indices, we'll get the total number of water that is trapped. Now the time complexity for this algorithm is O of n, because we're just traversing the array and building the left and right arrays as well, which will have a worst case of O of n. However, the space complexity is going to be also O of n. That's because we need to keep track of the left maxes and the right maxes in the left and right arrays respectively. That means at most we're going to be storing n elements in either one, and that's going to cause a space complexity of O of n. So for the algorithm, we can begin by initializing the left and the right arrays. Next, we want to loop over the height and create the left array. For this, we're going to write a for loop that goes from the start to the end of the array. Then we want to append to the left array with the current height if the length of left is 0, meaning that it's empty. Otherwise, we'll take the maximum between the current and the one that we've seen prior, which is the I-1th index in the left array. We do something similar for the right array, but instead of traversing forwards, we traverse backwards. So we can just modify this for loop a bit to traverse backwards, and also change how we append to the right array. And instead of left I-1, we'll change it to the last element in the array, which is just -1. Also, it's important to note that we'll have to reverse the right array. Next, we can go ahead and calculate the total water at each index. We can initialize a total variable and loop through . And again, remember the formula that we discussed, which is simply the minimum of the bars that we see minus the current height index. Finally, we can return total and submit. As you can see, it's accepted. We can actually write an algorithm that will have O of 1 space. Instead of having to keep the left maximum and the right maximum for each index in an array which will take O of n space, we can just use 2 pointers. Namely, we can have a left pointer and a right pointer at the start and end of the array. We'll also keep a left max and a right max, and initialize them with the height at the left and right pointers. So in this case, we have it 0 and 1. So for this algorithm, we're going to continue as long as the pointers don't overlap. And if they do overlap, we know that we've traversed every single element in the list. So first, we want the minimum between the two elevations. So really, it's the minimum between the left and the right pointers. And we can see that the left pointer is 0, the right pointer is 1. So we'll increment the left pointer. Then we'll update the left max if we need to. The left max currently is 0, and the current height is 1. So the maximum of 0 and 1 is 1, so we'll have to update the left max. Since we incremented the lower of the two elevations, we know that the water will just be the left max minus the height at the current index. We know that the left max is 1, and we also know that the current height at the index is 1. So the amount of water at this index is 0. Now we'll go through one more iteration. We see that the left max and the right max are exactly the same, so we can increment or decrement either one of them. For this case, just for simplicity, we'll just increment the left pointer. Again, we're going to update the left max. The maximum between 1 and 0 is still 1. And then we can add the total of the water, which is just the left max, so 1, minus the current height, so 0. And that will give us 1. So at this index, we know that there's 1 unit of water. For this algorithm, it's also going to be running in O of n time, and it's going to have a space complexity of O of 1 since we're not using any additional memory. With that being said, we can go ahead and write up the code for this. For the more optimal solution, we can go ahead and initialize the left and the right pointers. So 0 and the end of the heights array respectively. We can also go ahead and initialize the left max and the right max to both be the height at the left pointer and the height at the right pointer. We can finally go ahead and initialize the total. Because we're using 2 pointers, we want the algorithm to stop once the pointers overlap or cross. So we can say that while left pointer is less than the right pointer, we'll keep the algorithm going. Then if the height of the left pointer is less than or equal to the height of the right pointer, we can increment the left pointer. Also, we want to update the left max. So we'll say that it's the maximum between the left max and the current heights. Finally, we'll add any water at the current location, which is just similar to what we did previously. If this if condition fails, that means the right pointer is the minimum of the two, so we'll have to decrement it. Similarly, we'll have to update the right max. Finally, we'll add the water at the location. And at the end, we can just return total. And if we submit this code, it should be accepted. And as you can see, it's accepted. So hopefully you learned something from the video, and I'll see you soon.